Okay, we'll get started then. Yes, welcome to the modern ELT process, cloud computing and data extraction. Today we'll look at how cloud computing and virtually unlimited storage capacity has changed data extraction and data analytics. My name is Betty Kwan and I'm with the marketing team at ProServeIT. Presenting today is Scott Sugar, practice lead and for data and analytics at ProServeIT. And just a few notes before we get started. We ask that you please keep yourself on mute to minimize background noise. Feel free to come off mute if you have a question, or you can also enter your questions in the chat. We are recording the presentation and you will receive a copy along with the presentation deck for your reference. You should see an email within a couple of days. During the class, if you experience any audio or visual issues, we suggest you drop from the session and join again. And with that, I will turn it over to Scott.
Thank you very much, Betty. As Betty mentioned, we're going to be looking at the modern ELT process, and this is really setting the stage for the next session or the next class, which will be an actual live demo of an ELT pipeline setup. So I'm just going to dive right in. Again, as Betty noted, any questions, feel free to jump off mute and ask or type it into the chat window, and we can answer some questions too along the way, or at the end, we'll definitely have time for that. So agenda, real high level, we're going to just do a little groundwork where why are we processing data for data warehousing? If you've attended last semester's sessions, that's where we went through dimensional modeling and what that does for why we go through dimensional modeling for data warehousing, and the output of that dimensional modeling is typically the details around how you need to process data from the source to a target data model. And this here, the ETL/ELT side of things, is the actual processing of that data. So that's kind of, we're going to set some groundwork here around why do we process data. Then we're going to jump into, hey, here's the primary methods of processing data. We're going to have a comparison of ETL and ELT. So which one is best for which scenario, and what are the benefits and drawbacks of each. Then we'll dive into stuff that if you've joined some of these presentations before, you've already seen the data maturity matrix, but we'll jump through it real quick, and then what our customer journey looks like, and I'll move through that stuff at pace. So why do we process data for business intelligence? So the main points here are on the left side. So we want to clean and standardize the data. Data is coming from a lot of different sources in many situations. It might have errors, it might have duplication, it might have inaccurate data. So we really want to standardize it, put it into a format that allows us to do data quality checks and make sure that the data is actually relevant to what we want to analyze. Similar to that, again, we're integrating data from multiple sources. Because you're integrating data from multiple sources, you want to be able to process that data before just dumping it somewhere. The next, creating a data model that supports the business requirements. You know, that's kind of what we talked about in the prior semester around dimensional modeling, where we take, hey, here's the business process we want to analyze, and how do we then use data to analyze that business process? Improving performance, and there's two things here for improving performance. One is you're minimizing query load on your source system. So we've talked with clients before that are doing all of their reportings out of their ERP system, right off of the database of their ERP system, and we're saying, hey, we've got a couple heavy reports that take 24, 36 hours to run, and while we're running them, half of our team is complaining about how slow the ERP is. And that's because they have that ERP database doing a lot of complex joins and analysis that database wasn't really meant for. So it's going to minimize load on your data on your source systems, and then if you're processing the data properly and preparing it for querying, you can actually speed up the report generation. So the client that we had that had 24-hour report generation, we've taken that, moved it into a really high performance analytics system, Azure Synapse, and now those reports are generating in under 15 minutes. The exact same report that took 24 hours before is now being built and is now generating on demand in 15 minutes, and they can run about 30 of those reports at the same time, whereas before they could only run one. So we've increased concurrency as well as performance by taking this into an analytics system that's built for read speed instead of write speed, which is what a lot of source systems are for. And then finally, preparing the data for the analysis, very, very similar to creating the data model and preparing the data for that analysis. Any questions around why we process data for business intelligence before I jump in further? Cool. So first we're going to look at ETL, stands for extract, transform, load. So ETL has been around for a long time, at least 30, probably 40 years now. Again, it stands for extract, transform, load, and what it's doing is you're extracting data from your source system, you're transforming that data, and then you're loading it into the data warehouse after as fully transformed, clean, modeled data. So that's the ETL process. Any questions about the ETL process? And we're going to jump now to the ELT process, which sounds very similar, extract, load, transform, but there's some key differences, and we'll get into those. So the term ELT, it's a more recent term, and what caused this is that we started to have data warehousing systems that could process data very powerfully. So in database processing capabilities, systems like Snowflake, like Azure SQL, like Synapse, Amazon Redshift, these systems make processing data, large amounts of data very fast. And again, you're already using these systems for data warehousing. So doing that transformation within those systems means you have one less tool to work with as well, instead of needing to have a specialized ELT tool that sits outside of your data warehouse. So in ELT, your data is extracted from the source system, loaded directly to the data warehouse as is. So you're essentially taking a copy from your source system, dropping it into what people would typically call a staging table in the data warehouse, and then executing your transformation, whether that's done through a stored procedure, or whether that's done through other systems that allow you to transform it. That's where that's happening. And I think we've talked about in some of these sessions before, we've talked about the data lakehouse, which is a data lake plus a data warehouse merged together. And that is also using this ELT system where you're taking it from your source system, landing it into the lakehouse in its raw format, then doing your transformation to move it from that raw format in what they would call the bronze table to the silver and the gold tables, all within the same processing system. And finally, ELT, often faster and more flexible than ETL, because these modern data systems are designed to handle large-scale data transformations. Any questions about ELT? I'm going to dive into the comparison and hopefully this highlights why ELT has become the more popular way of handling data transformation. And if you look at everything Microsoft or Amazon or Google are doing in this space, it's all based on ELT now. People still use the term ETL because it's widely known, but even though they say ETL, typically they're talking about ELT. So from an ETL perspective, we have the features on the left side, and then we've got the comparison here. So for data latency, that ETL can take a long time to run because you're doing the processing in the middle. By the time the data is loaded, it might already be outdated. ELT can be faster because the data is loaded directly to the data warehouse and transformed there. And you can even use that raw data in some analysis if you need real-time or much faster data access. A bit outside of what we're talking about here, but another trend I've seen more and more, especially with medium and large companies, is that there are analysts in these companies that don't just want the clean data. And one problem with ETL is you're doing the transformation in a black box, sending that to the data warehouse, and then providing your analysts access to that cleaned in model data. And what we've been finding more and more recently is that there are analysts that come to us for these large companies and saying, hey, I need the raw data because I need to see, I need to check for some patterns that you're cleaning out of the system. And so then it's okay, well, let's get the raw data available. Now, if you go ELT route, the raw data is going to be available already as a staging table or a bronze table. So your analysts can then use that raw data in their own machine learning models, AI, or they can help process it for reporting purposes. Flexibility. So ETL, it's not as flexible because any change to the transformation you're doing in a different system requires significant effort, and then you're going to have to modify potentially the data warehouse as well, because now it's potentially loading different data types, different structure of the data. In ELT, it's a bit more flexible. Now, there's still going to be some work involved when you want to make changes to the transformations. But typically, because all of that's happening in a single system, it's a bit faster and easier to work with. Scalability, again, the ETL systems, a lot of the times you're doing that transformation work in its own server that's doing your transform, whether that's using SSIS or Power Center from Informatica. Like, you need that machine that's doing those transformations outside of the data warehouse. And now if you need more processing power, you're scaling up that. If you need more storage, you're scaling up your data warehouse. With these modern systems, what you find is something like an Azure Synapse, you can scale up or you can scale out. So you can tell Azure Synapse, hey, I don't just want more processing power. I want you to spin up 60 of these nodes and actually partition my data in this way so it splits that data out. And now I'm processing across 60 different computers, and all of that complexity of being able to do that is handled by Synapse or Redshift or Snowflake, instead of you having to worry about, okay, how do I scale this virtual machine that's running SSIS or Power Center to do that? Data quality. Now here's one spot where ETL is typically a little bit better, because you're transforming it into a common format before you're doing the load. You can apply some quality checks here, as well as down the path, and some of that actually becomes a little bit easier in some cases. In the ELT, you probably need to layer on some data quality checks in the data warehouse. There are tool sets out there now, something like Great Expectations, that allow you to build out data quality rule checks, which is pretty interesting, and now layering that into the data warehouse level, both at the raw data and at the model data. The complexity of ETL to design it and implement it, especially with very different data sources, can be tricky, and designing it in those systems, doing all the transformation in there, is often a little more tricky than in the ETL scenario. Because all the data is sitting there in larger staging tables, you have all the processing power. And then if you're looking at that lakehouse architecture, now you've opened up your toolkit to say, hey, if I want to do this processing in SQL, I can. If I want to do it in Python, I can. And you can start playing more towards where your team's skill set lies. The cost of ETL versus ELT, again, because you're using specialized tools and additional transformation machines, it's typically more expensive than having a data warehouse that just does everything for you. And again, from a maintenance perspective, it's much easier to just have a single data warehouse that's doing your transformation steps for you there. I know we just went through a whole lot of information. Any questions about any of this? To round it out, just to give our recommendation is you should always be looking at the ETL process. Like we said in some of our prior things, you should always be looking at how do I do this in the cloud, because the amount of data growth that is being experienced now and going into the future is going to be exponential. I think a lot of the Gartners and Foresters of the world are predicting companies, even small companies, are going to be seeing 35%, 35 to 60% data growth year over year. So that's compounded data growth. So you're going to start seeing, if you're not already, and a lot of companies are already, but if you're not, in the next few years, you're going to be seeing that, to use a Canadian analogy, that hockey stick ramp up of data growth, and trying to scope out on-premises or even virtual machines to handle that is going to be tricky. Whereas putting all of this into a Synapse or a Redshift means that you don't need to worry about the amount of data that you're going to be dealing with. You can scale up to petabytes, and you can start very small at gigabytes if you need to. I've put together a little list of ETL tools out there, not in any specific order, other than I put Data Factory at the beginning because that is the tool that we're going to be using in the next lesson, where we actually build out a data pipeline in a system. So walking you through, hey, here's how we're extracting it from a source system. Here's how we're loading it into the target system. And here's how we're going to trigger a transformation on that data to model it for reporting purposes. And then we've just got a little thing here. And I think, Betty, this deck, as well as these slides, as well as this presentation, will go out to everyone attending, so you can look at these.
That's right.
Yeah. And then again, I would really focus on what's available in the cloud. And just to note, I would say just keep an eye on what's in the cloud. I know Informatica has a new product out that is fully cloud-based, and I think a lot of these companies here, especially the commercial licensing ones, they're all going to be moving their products to the cloud as rapidly as possible, if they're not already there, with probably the exception of SSIS, which is just being replaced in the cloud by Azure Data Factory now. The other thing to note is that you're going to start, I've already seen a lot of vendors packaging up something like Apache NiFi, which is a fully open source system, taking that, packaging it, and using it in their cloud-based solution. So vendors like Starburst, what was the other one? Cloudera, that have these very wide data platforms that do a whole bunch of stuff, and they're piecing together all these open source systems to do that while supporting it and everything. So Again, some of these say on-prem or cloud versus cloud. Some of that is depends on the vendor you're going through for this stuff too. Cool. What's next? So the next session will be that live demo. So we're going to all sit down together with the Data Factory and a couple SQL, Azure SQL servers, and get a basic ELT pipeline up and running. As long as all the demo gods work out for me. So that's kind of the bulk of this presentation today. I hope everyone learned a little bit about ETL versus ELT, that terminology, because I know that can be a bit of a gray area sometimes, and why what you're seeing in the market is more and more vendors positioning ELT as the correct way forward. And then just to walk through, I know this is really tiny. Maybe I can zoom in a bit. So what we see with clients in level 1, there's a lot of spreadsheet reporting, complex Excel formulas. There's a lot of manual cut and paste from source system to report. There's a lot of difficulty in integrating multiple data sources without really complex, VLOOKUP if statements inside Excel. And there's often a dependency on key individuals for knowledge about how that report was built and how it's maintained. What we try and do with clients during the initial level up project is do a set of baseline reports, build out the automated data retrieval, make sure that we can integrate multiple data sources. We build out the whole data infrastructure to support all of that. And then as clients continue to progress down their journey, we start to see clients doing integration of external data sources. An example of this, we've worked with a large private company. All of their competitors are public companies. We're able to take that competitor's public financial information because it's all in public and compare that back to their private financial information so they can see how they're doing compared to their competitors. So we're starting to grab external data sources and make those part of your analysis, layering in AI, ML, building out mobile dashboards and scorecards. We had a client that had salespeople going out to customers and being able to see everything about that customer as they're taking an Uber to the customer was very powerful for them. And then, our standard customer journey, we do our discovery project. We're assessing what's happening currently in your data practices, figuring out where you are on that maturity matrix, building an implementation plan, helping you understand the costs and the ROI. Then going through that basically implementing that plan, including building the data infrastructure, and then the data journey is not one and done. Business continues to evolve, so we help you continuously improve your data practices. And then we also provide strategic advice from senior consultants, retrieve requirements. We have processes to retrieve requirements out of users. We also allow clients to push requirements to us to help them continue to expand their data-driven processes. That's all I've got for today, and I think we've got 2 minutes remaining. Happy to field any questions.
Add a couple of links into the chat while we're waiting for some questions to come in here. I think Sam is typing, so you might see a question there. Okay, so the first link is for our data and analytics discovery package. So have a look there if you're interested to see the details. And we'll also include this in our follow-up email. And also the next session that Scott mentioned is on March the 28th, when we'll do a demo on the Azure Data Factory. And I put a link there for for a description if you'd like to see that. You will automatically get a reminder for this session since you are already registered for our data analytics course. And Sam just says, I do not have a question, but I want to say thank you for preparing this session. Thank you so much, Sam. We really appreciate the feedback. Okay, if there are no other questions, we will, I guess we'll say thank you very much for joining us, and look out for the links for the recording and presentation deck in a couple of days. Thank you. Enjoy your day, and thanks for an awesome session, Scott.
Thanks, Betty.